Cirrus Migrate Cloud, CMC, is a patented solution created to help customers move data from anywhere to anywhere. With our newly announced integration with Silk's platform in the cloud, Cirrus Migrate Cloud users can easily migrate any workload from any source to their new iSCSI-based cloud-native software-defined storage with minimum interaction and interruption. Being a migration-as-a-service solution, Cirrus Migrate Cloud collaborates with storage vendors to create purpose-built integrations that not only automate various configuration steps, but also follow best practices for specific storage products. Silk is a flexible and scalable virtualization platform. With CMC's new integration with Silk, users can now easily perform live migration to Silk from anywhere and any storage and start benefiting from Silk's platform with minimum impact to your production. And most importantly, with CMC, you can skip the tedious tasks surrounding manually setting up the destination storage and migration configuration. For this demonstration, we will be migrating a Windows and Linux host workload from Azure Managed Disks to Silk on Azure. Let's first go over our demo environment. This is a Linux host. It's a Red Hat 8 Linux host running on Azure, and that's why it does not have any iSCSI initiator software or multipath software installed. Our workload is using data from these two 4 GB Azure Managed Disks that are mounted to /data1 and /data2. We also have a Windows 2019 host with just one 128 GB C drive. Just like the Linux hosts, iSCSI Initiator is not configured, and there are no customized MPIO configurations. This is the Silk instance that we would be migrating to. It's running in the same Azure subscription and in the same subnet as the application hosts. This is a brand new installation, so no volumes or hosts were created. Only default volume groups are available. This production-ready Silk instance also has multiple network interfaces for data access. CMC will automatically configure the hosts to make use of all of them automatically later. Let's get started. First, we'll go to Cirrus Data Cloud and create a new project called Silk Migration. After the project is created, let's first go to our user license key. Here you can purchase licenses if you need to, but in this case, we already have the license, so we'll just transfer it to our Silk Migration project. Now let's go back to the project we created and deploy CMC to the hosts. Let's deploy CMC on the Linux host first. From the Migration Host screen, click on Deploy Cirrus Migrate Cloud and copy the installation command for Linux. This same command can be used to install as many hosts as you like for this project. Back to the Linux host. Paste the curl command in the shell and CMC should install and register to Cirrus Data Cloud all by itself. The host has successfully registered to Cirrus Data Cloud. So let's go back to Cirrus Data Cloud and see that our Red Hat Linux virtual machine has been registered to the Silk Migration project, and it shows that it's running in an Azure environment. Clicking on the host, we can see that CMC has discovered the 4 GB Azure volumes that are currently mounted to /data1 and /data2. Along with other system information. Next, let's also deploy CMC on the Windows host. Copy the installation command for Windows. Paste the command in a PowerShell window, and CMC will install and register to Cirrus Data Cloud all by itself. This time, we can see that the Windows 2019 Server virtual machine in the Azure environment has automatically appeared. And there is a 127 GB C drive. CMC is deployed on both hosts, and we're now ready to migrate. Normally, this is the time where we'll head over to the SSH session, remote desktop, or some web portal to properly connect the host to the destination storage. But with Cirrus Migrate Cloud's iSCSI storage integration, you don't have to do that. Let's spend a little bit of time reviewing CMC's automation and integration capabilities. When using Cirrus Migrate Cloud to migrate to iSCSI storage, with just one click, CMC's integration will automatically scan and detect your VM's configuration, install iSCSI initiators and multipath drivers if necessary, configure the iSCSI initiator, UDEV settings, and MPIO based on best practices, create host entities on target storage with proper initiator IQN, automatically allocate destination volumes that match the existing source volumes, map volumes to the migration target, identify volumes based on different storage vendors' identification scheme. Without Cirrus Migrate Cloud's integration, users will normally have to manually perform all of these tasks before migration can start, regardless of which migration solution is being used. Back at the demo, let's add the Silk integration to the project. We only have to do this once, no matter how much data we are migrating. Go to the Integration Catalog, scroll down to the iSCSI Storage section, and select Silk Data Pod. Click on Add Integration. Here you will enter a name, management server address, username and password. Let's also select the Linux host for the connection test. And here we can see that it worked. We can see that we've connected to Silk successfully. And the name, version, and serial number are correct. The Silk integration is now created, and we're ready to migrate. Let's create a migration session. From Migration Hosts, select our Linux host and click on Migrate Host Volumes. For this demo, it will be a local migration and data volumes only. Click Continue. We'll be migrating both SDA and SDB, the 4 gig Azure managed disks that are mounted to /data1 and /data2. Since we have the integration set up already, we'll click on Auto Allocate Destination Volumes and let the integration do all the work. Select the integration we previously created. Here it shows that the host is not ready for auto allocation because CMC found that the iSCSI initiator is not installed. You can manually configure it, or you can just let Cirrus Data Cloud configure the host for you based on best practices. So let's do that. And now the host preparation operation has been completed successfully. Let's quickly review what CMC has done to this Linux host. The iSCSI initiator and multipath are now installed. Silk-specific multipath configuration is added. Silk UDEV rules are also created automatically. Let's take a look at the Silk platform. A host with the same name as our Linux host is also created automatically, and it already has the correct host IQN entered. Let's continue the auto allocation process. Here you can customize the volume group property for each volume, or you can leave it as default. Let's continue and let Cirrus Migrate Cloud do the work. The first volume is created with a serial number. It's now allocating the second SDB drive. iSCSI is attempting to log in. It's then connecting to the iSCSI target, identifying the new volumes, multipath devices found, and everything is connected with just one click. And now everything's done. The 4 gig destination volumes are allocated, identified, and paired up with the source volume. From the Silk Web Management portal, we can see that 2 new volumes are created and mapped to the destination host correctly. The same exact steps we just did now apply to Windows as well. So let's cut to the Windows demo. For the Windows migration, we have a 127 gig Windows C drive. Let's perform auto allocation too. It's connecting to Silk, and it's checking the iSCSI IQN. The host readiness check also fails here because the iSCSI target is not discovered. So let's use configure host for me as we did previously. It detected the Windows IQN, is preparing the host MPIO configuration, and the host is now prepared for migration. So let's check what CMC has done automatically. We can see a new host entity was added for this VM with the IQN correctly entered. From the Windows VM, we also see that a Silk iSCSI target is now discovered. And the Silk vendor string has also been added to the MPIO automatically. That's a lot of manual tasks that CMC has automated. Let's allocate. Again, it will perform an iSCSI discovery and allocate volumes based on the source volume. Allocation has completed successfully. Let's confirm that on the Silk, a new 128 gig device has actually been created. And we can see it's mapped properly. From the Windows server, the iSCSI target is connected, and the devices are discovered. Because of the multipath settings that were automatically entered, we already discovered a 128 gig device. It will remain unallocated because we have not migrated yet. The source and destination volumes are paired as well. We'll be migrating from a Microsoft Virtual Disk NTFS to the Silk iSCSI device. Now that the destination volumes are prepared properly on both Windows and Linux hosts, let's continue setting up the migration session for our Linux host. Here you can also configure a migration schedule and select your IQOS setting. IQOS is a purpose-built feature that intelligently minimizes the impact of migration, allowing CMC to migrate as fast as possible without impacting production I/O. You can view our other presentations to learn more about IQOS. Let's create the migration session. Migration has now started. From the migration screen, you can monitor the migration performance and other statistics, such as data reduction and the data change rate. This is a live migration, so let's go to the source Linux host and simulate some live writes to the /data1 directory using dd. As you can see, all new writes during migration are detected and registered on our change data map. We can always trigger synchronization again until we're ready to cut over. Since this is a demo, let's proceed with cutover. First, we'll trigger cMotion. cMotion is a reversible state where CMC will redirect all I/O to the destination volume immediately without requiring any application downtime. This allows users to immediately benefit from new storage even before a cutover can be scheduled. At this moment, /data1 is still an active mount point for SDA, which is still the original Microsoft disk. However, when we continue writing to this, we can see from the Silk GUI that the host is already accessing the Silk volume instead. As we said, cMotion is reversible. From the change data map, we can see that changes continue to be tracked. This allows you to revert cMotion and move production back to the original state without requiring a full volume copy. Let's proceed with the final cutover. From the Action menu, select Finalize Cutover. We will unmount SDA, complete the session, and mount the Silk device back to /data1. With less than just a second, production workload is now accessing the Silk multipath device directly, and our 1 gig file created during cMotion is intact as well. The entire cutover process took less than a second. Migration is now complete. You can also generate a migration report that includes detailed information about the migration operation. You can view it or print it out for a permanent record at any time. And this concludes the demo. We've successfully used Cirrus Migrate Cloud to configure the host, configure the Silk platform, allocate and discover new storage, and most importantly, migrate the data from the Azure managed disks to our new Silk platform without any impact to production.